Hello students, welcome back. Let us resume our discussion of section 2. Here's a reminder on the standard rule. Take the derivative from the right hand side, you're going to get back to the integrand. This one too. But these expressions are not general enough. Let's expand it a little bit further. Ax plus b to the k power, ax plus b to the negative first power, exponential of ax plus b form. So we have ax plus b inside. Now apply the antiderivative rules. The same rules apply. So increase the power by 1 and divide. Natural log. Exponential remain the same. And then don't forget 1 over a. 1 over a. 1 over a. The reason we have to undo the chain rule. Take the derivative here, for example, exponential stay the same, and we have to multiply a by the chain rule, and that collides with 1 over a, and then disappear so that we get this original integrand back. Same here, take the derivative, log becomes 1 over ax plus b, and then we have to multiply by a by the chain rule. This 1 over a kills it so that we get the integrand. Same here, take the derivative, k plus 1 comes out and collide with 1 over k plus 1, they disappear, and then subtract 1 from the power, so we have the k power, but that's not enough. We have to multiply by a due to the chain rule, and that collides with 1 over a, and that disappears as well, so that we have the same integrand as we started off with. So that's the idea. We need the recurring theme of 1 over a. In a special case, when a is 1, we get these standard cases. And then we went through some example problems on power rules. 1/2 power, negative first power, and negative 3/7 power. Now let's work out some exponential functions. The first problem here does not have anything to do with this ax plus b, but let's talk about it anyway. What's the antiderivative of e to the x power? Well, that remains the same, natural exponential, of course. So that's blue. And what's the antiderivative of x to the e power? It's a power function, so power comes out as coefficient, and then subtract 1 from the power. So this thing here, red, becomes this, red, the power rule. And then e to the e power, what happens to that? It becomes, did you get it? It becomes 0. Why? There's no x there. Let me expand the font. There's no x there, e to the e power, just a constant. And the derivative of the constant is 0. Antiderivative of constant is not 0. Excuse me, my mistake. My mistake. E to the e power times x. Okay. As a matter of fact, I just demonstrated some common mistake. When you have constant, derivative of constant, so we get 0, but antiderivative of constant is the constant times x, but sometimes you make some stupid mistake, just like what I just did here. Sometimes I make mistakes intentionally so that, give you guys some chance to catch up, but that was my real mistake actually. Anyway, you got it right. Exponential stay the same, power rule, and constant. Alright, now what's this? This brown. X over e. Do we use some quotient rule or something? No, as a matter of fact, this x over e can be written as 1 over e times x. So what is this? This is just a coefficient, and this is a power function, just 1 power. So what do you get here? 1 over e and then raise 1, and then divide. So that's the antiderivative. That's the brown part. Finally, what is e over x? Again, don't think about quotient rule or anything like that. There's no such a thing. E over x is actually e times x to the negative first power. So this is just a coefficient, and x to the negative first power, that'll give you a log function. So this one here, purple, becomes like this. E stay the same, and log of x. Let's keep it purple. So that completes the problem. And please check, each color corresponds to, well, corresponding color. Those are the antiderivatives, and they're written in the same order. Do not change the order here. I know addition is commutative, so you can change the order without changing the quantity, but if you do that, the answer may remain the same, but you lose the justification. Which term came from what, and which antiderivative rule you used, they're going to be all lost if you change the order. Even worse, if you just type this one into some computer algebra system, some free websites such as Mathway, and you're going to get some answer, and you just copy it, you get the correct answer. Yeah, but that's a plagiarism. You're not going to get credit for that. You have to justify on your own, and each justification must show which antiderivative rule we just used. You can emphasize by coloring, of course, and that's the most ideal. But you don't have all those colors available to you most of the time. In that case, at least keep the same order. First term must come from the first term. Second term must have come from the second term, and so on. So keep the justification intact. Here's the answer key. The same thing. Even the color coding is the same. Okay, now, do we have enough time for this one? Okay, let's go ahead and do that, but we have fraction and some powers, so some bigger font will be in order. Now, what's going to be your first reaction here? Can you separate the numerator as the way you did for section 1? Remember these problems? This one, and also that one? That's what you should do. So let's copy and paste this thing. Put parentheses here. And then, okay, remove those. That's the first term. And then 4 e to the x minus 1 power divided by 2 e to the 3x plus 2 power 3 over 2 exponential of 3x plus 2 power. Okay, all right, let's continue. Let's see, this is the first term, by the way, and this is the second term, and this is the third term. And the first term here became the first fraction, and this became the second fraction, and that's the third fraction. Keep the color coding so that you can see what came from what. Now this is 1/2, and then exponential of what? Think about that. The number part here is 4 over 2, so that's 2, no question about that. And how do you simplify this? Finally, this one, the number part is 3/2, and then exponential of what? Would you like to stop the playback and figure those out? You'll have to do this. A to the any power, m power, divided by a to the n power is a to the m minus n power. Remember this? The exponent rule. You can use this. So we're going to subtract 2x plus 1 minus 3x plus 2. That's going to be this question mark. This power minus that power. So what do you get? You get negative x minus 1. Does it look right? 2x minus 3x, 1 minus 2. Likewise, you can do the same thing here. X minus 1 minus 3x plus 2. So x minus 3x, so that's negative 2x. And negative 1 minus 2, so minus 3. Finally, how about this? Well, numerator has 0 power, so nothing to think. It is negative of that, negative 3x minus 2. Okay, let's complete this computation. And, oh boy, I think I got a bit carried away. Font is a bit too big. Well, yeah, okay, that's still okay. It's still legible. So let's go with this. Okay, how about the antiderivative of this? 1/2 was there before. Exponential never changes. And then we need 1 over negative 1. Remember, we need this 1 over a. So that's blue part. Now let's go to green. 2 was there before. Exponential of negative 2x minus 3. Nothing changes. And then we need 1 over a. Oops. Now 3/2. Oh, by the way, this is green. 3/2, and then exponential stay the same. Negative 3x minus 2. And then we have 1 over negative 3. We need 1 over a. So this is brown. And that completes the problem. You can simplify this to negative 1/2. This one is to positive 1. And this one is negative 1/2. But I didn't bother. That's just a simplification. What did I do in this answer key here? Yeah, negative 1/2. And then negative 2x minus 3, okay. Positive, and then negative 1/2, okay, all right. Enough time for one more? I guess not, so stop the playback and try this. Did you get it done? Well, let's see. Step 1, separate the numerator. Yeah, okay. And then subtract the powers. Oh, we have a wrinkle here. 3y cancel out. Let's expand the font. 3y cancel out. We have 2 minus a negative 5, so e to the 7th power only. And that's just a constant. So constant times y. The others are pretty much the same as before. So there's a bit of a wrinkle here, but elementary. Still elementary. Okay, so much for section 2.